In this video, we will take a look at another implicit derivative problem. We're going to go out and find the equation of the tangent line that intersects the equation x squared minus y cubed equal to 4y plus 9 at the point 2, negative 1. So to find the equation of the tangent line, overall, we need to first find the tangent line slope. We'd like to find the tangent line slope. And to do that, we want to find the derivative dy dx evaluated at our point, 2, negative 1. That's going to get us our tangent slope. So this is the overall goal to start with. Then we can fill in the other details of the tangent line. So let's start with finding the derivative, evaluating it at our point, and then we'll take a look at constructing the equation. So let's start by considering the derivative of this function, dy dx, on both sides. So on the left side, we'll take a look. This is going to be just 2 times x. We'll have a minus y cubed. We'll have the chain rule here. So that'll be 3y squared. And the inner function here is just the y itself. So the derivative is going to be dy dx attached to that. Next, we'll have the right side of the equation. This will give us 4 times y is going to be 4 times dy dx for the derivative. And then the 9 will just be a constant, so that has a derivative of 0. So next, let's go out and find and isolate here dy dx. So I can add on both sides here 3y squared dy dx plus 3y squared dy dx. These two will cancel. I'll be left with one non-derivative term, which is the 2x term. That will remain. This will be equal to, we'll notice there's 2 terms here on the right side, and I can distribute there the dy dx term, and I'll be left with 2 individual pieces. That would be a 4 and a plus 3y squared. So we'll write that in parentheses there, 4 plus 3y squared. And one last step we can take to find our dy dx is to divide by everything on the right side. So when we rewrite this, I can say that dy dx is equal to, the numerator is going to be 2x divided by 4 plus 3y squared. So we found the general derivative of this implicit equation. Now we'd like to go out and actually evaluate this at the point given. So now we're after our slope. To find that slope, we're going to evaluate the dy dx at the point 2, negative 1. You'll notice that the derivative is dependent on both x and y. So when we go to evaluate, we'll evaluate at x is equal to 2 and y is equal to negative 1. So let's do that. In the numerator will be 2 times x is another 2. Divide by 4 plus 3 times y squared, which is negative 1 quantity squared. When I simplify this result, we'll have 4 divided by 4 plus 3 times negative 1 squared. That'll just be another 3. So 4 and 3 will just give me 7. So the slope, the tangent line slope, is equal to 4 over 7. So some would call this m sub t, the tangent line slope. So we've got our tangent line slope, and we have a point, the point 2 comma negative 1. So we can start to write this tangent line with the point slope form. So we know that, just as a review, our point slope form for a line, we know this is going to be y minus y1 equals mx minus x1. So let's fill in the gaps with our points in slope. This will be y minus negative 1 equals my slope of 4 over 7 times x minus x1, which is 2. We can rewrite this in slope-intercept form if we'd like as well. So we've got y plus 1 equals 4/7 x minus 8 over 7. And if we subtract 1 on both sides, subtract 1 and subtract 1, we can give our y in slope-intercept form. We'll still have 4 over 7 as our slope, and then our intercept is negative 15 over 7. So there's our slope-intercept form, and we have our point-slope form above that. It might also be helpful here to kind of visualize what the result we actually got. So let's take a look at Desmos for just a moment to visualize what we've just found, the tangent line equation for this. We have our function, or at least the implicit equation in red, and our tangent line equation in blue. We'll notice that this tangent line equation crosses the graph of our red function here at 2 comma negative 1. That's our tangent line. So this is just a little bit of what it would look like if you want to double check your work and see if you got that tangent line equation correctly. You could always use Desmos to visualize if you have that implicit equation and its tangent line correct. So thanks for watching this video. You can check out my other videos on this subject if you'd like a few more examples. Thanks for watching.